Hi, good morning all. Today we talk about the thread scheduling. So earlier, in earlier previous session, you have learned about the thread. Thread is a lightweight process, and one task or one process can break it down a thread, and thread can using thread we can accomplish the parallelism and concurrency. Okay, that thing you get. If you want to revisit, you can check Java playlist, our playlist. In today's section, we talk about what is a thread, what is a rescheduling, what is required, why it's required for thread scheduling, how it's happen, internal of the thread scheduling, examples and interview questions around the thread scheduling. Okay, this is the today's content section. So thread, we know that this is a lightweight process, and each process have the multiple threads. Like process can break down into T1, T2, T3, and all the three T3, these three things are work parallelly. So suppose, for example, if you are in earlier section also we take this example, if you are working on any document, if you want to source any image and image size is 100 MB and you are downloading that and ingesting into your document, so this process will be done by thread 1. If you are writing something code, that code writing by T2. And suppose if you hold some code for the copy paste, that is copy from certain things and pasting here, so this is a T3. Okay, or there are some plugins which are auto correcting the R words or grammatically and spelling mistake are doing here, so that is a T4. Okay, so combining the T1 to T4, all these are your part of your P1, which is a document process. Okay, this is known for the threads. And okay, let's discuss about the thread scheduling, how internally thread scheduling happen. So there are multiple parts. So basically threads like here, like T1, T2, 3 are there, but CPU take a first time based upon the first come first serve. Like T1, it came into your system first, then CPU serve on that basis. But this is not only one criteria. There are total 3 to 4 criteria to choose which process CPU should schedule that. So first criteria is the first come first serve, like based upon the priority, based upon the arrival time, we can call it arrival time. So based upon the arrival time, the JVM pick the threads to the schedule. Means JVM, implicitly we are calling CPU. So CPU took this arrival time AVT. Based upon that, the thread scheduling happen. This is the first criteria. Second criteria is the, suppose there are one thread, so T1 to T4 we receive in a pipeline, but a T1 required to complete a 10 minute or a 10 seconds, and T4 required to complete a T2, T3 and T4 are combinedly complete within a 1 second. Okay, combinedly complete within a 1 second. So waiting for T2, T3, T4 is a 10 second, because T1 is a huge process, and to complete this, that much time need to wait. So to avoid certain situation, like here all the three processes are waiting on a T1, and T1 is took by the 10 seconds. So to avoid certain situation, time slicing happen at a CPU level. Means suppose the T1 execute, T1 required a 10 seconds. So firstly 2 seconds run by T1. Okay, T1 executed 2 seconds, so 8 seconds are remaining from T1. Then T2 get executed, because T2 we are saying 1 second T2 get completed. Then T3 also get completed in a 2 seconds. So this time frame get completed 2 seconds. Again T1 get scheduled. Okay, T1 get scheduled here. So left time is a 6 second, and here 2 second get executed. Then T4 get executed within a 1 second, and after that remaining 6 second executed by T1. Okay, this is why the time slicing is required, because in this due to this time slicing, this is the way where we are scheduling using the time slicing. So this is the second factor. First factor, we check about the arrival time, AVT, arrival time of your thread. Second is the time slicing. Third is the primitive scheduling. Okay, we'll check about the what is meant by primitive scheduling. So primitive scheduling means, suppose every thread have the priority. Means priority is defined by P. So from 1 to 15 is the priority. So consider, so highest priority, that means which is a more required work to do. Okay, so in here, like 1 to, first we are executing one thread with the priority 6, and in our pipeline thread 2 is there which have the priority is a 2. Why we are executing 6? Because 2 have the lesser priority, so it's waiting till this time 2 seconds get completed. We are just, for example, we are considering 2 seconds as the time slicing. So after 2 seconds this gets scheduled into pipeline. But once 1 second get completed, till that in our pipeline the next thread come, which is a thread and priority is 7. So immediately this thread get paused, and then thread 7 get executed for a 2 second. Like the same time slicing is the same. Based upon this, T7 if complete within a 10 second, then it is okay. Or then if 2 seconds get completed before the threads get completed, then we are jumping over to this thread 1, which is a 6 second. Okay, same way happen, but just which one should get earlier priority or for the earlier execution that based upon this primitive priority. So based upon a priority, if new threads are coming into pipeline, we are deciding whether should we provide the priority over the current execution. But that doesn't mean ki current execution get halted or current execution get suspended. It just pause for a certain time. After the time slicing of the new process or a new thread, after that time slice get completed, the CPU jump over to the previous thread which is paused due to the new pipeline push into new thread push into our pipeline. Okay, that means that is known as a primitive priority. Okay, in this example or in this diagram, suppose if you are see all the three are we are applying, like here thread 1 is a priority 7, then 5, then 5, 4 and 2. Okay, this is a sorted based upon the descending of a priority. So the processor first check for first come first serve, means which is arrival time first, we are picking on that. Based upon that, each and every process are run for the certain time and the primitive priority getting scheduled, like recently we discussed about the primitive priority. So based upon the priority descending, it's get time allocated. So based upon the three rules, Java scheduler or the Java thread scheduler decide which thread get a prioritized. Okay, that's it for today's session. Let me know if you have any doubt on the thread scheduling. We'll connect and discuss it. Thanks all. Bye.